So with what is left today, we're going to do vertex form, descriptive form. You may recall from our first lesson that there were three forms of the quadratic equation, right? Recall that the general form has no brackets. It doesn't hurt, right? This doesn't hurt. You know that something is in general form and you don't see any brackets in it. And B and C, I have to say that may be 0, okay? A cannot be 0 because then it's not a quadratic anymore. Then it's linear. Vertex form, it provides you with the direction of the opening with the number of x-intercepts and the vertex. Most importantly, the vertex actually, just like that. It looks like this. Okay, this is the general form of the vertex form, and recall that A is in front. A is still doing the same thing as before. Let me just go and get my booklet for that section. A still tells us the width and the direction of the opening. That hasn't changed at all. And the rest is going to be a little different. Here. I just want to stick with my script. Don't go off the script, that's why. Determines the direction of opening. Is it positive, right, or negative? Let me just zoom out a little bit and focus here. There you go. Okay, and then it also determines the width. So nothing new there. But remember, I used to teach it in this order, so this would have been way after, right? So I had to kind of remind everybody. The width, so I don't know. I don't want to do the whole thing. So wide, narrow, normal. Okay. And if you need more, go back to the first lesson and you'll know how to determine that. It's still the same. If it's between 0 and 1, bigger than 1, exactly equal to 1. Okay. So here's the kicker. The vertex, if you look at this, if you notice, hey, there's a bracket, right, like that. The vertex is going to be, I'm going to use a different color here. It's going to be negative HK. And what does that negative do? Changes the sign from the equation, okay? Changes the sign of H from equation. Sorry, this is how I write equation when I don't want to write the whole thing, okay? Equation. So that's very important. K stays the same, right? K is unchanged. So you will copy it exactly the way it is over here. So that's our vertex just from reading, just from looking at it there. So if I gave you something like this, okay, you should immediately recognize that this is in vertex form. Why? Because there's a bracket, right? Bracket, bracket, right? So they get ugly, right? They get kind of weird. That's what's different between us and pre-cal. Pre-cal, they can only solve things that factor out nicely. They can't do anything else, right? So we deal with anything, just give it, right? Like we'll solve it for you. We'll answer the question, okay? So here we go. There's a lot of overlap between you and pre-cal. Like when you go through all of this, they learn about the same thing. You just do it differently, okay? I love applied, to be honest, over pre-cal, but some will disagree. Oh, now it's recorded. Don't tell anybody. Direction of opening, we still do the same thing. Down. Okay, why? A is negative. A is negative. width, normal, right? It's a normal width compared to if you were to graph the exact same one with a different a value. This is the normal one, right? A is equal to 1. Okay, you just look outside the bracket, there's nothing there, so it's 1. Vertex, watch this. I will go look at this value right here. What is it? +4, right? So you're going to go ahead and say, no, it's going to be -4, right? And then the value of k is 5. And if you have a highlighter, I'm just going to say that, I'm just going to highlight that part, right? This changed. I changed the sign of the x value. Whenever it is inside the brackets, when it comes out, it changes, okay? I will explain that to you maybe next week. Y-intercept, 0, 5. Right, Mr. Drayson? Can't do that because this is not in general form. So how do you find the y-intercept? Second, I had to think myself there. Second trace 1, x is equal to 0. You have to use your calculator for these ones. So let's go ahead and do that because you need to learn how to type this in, right? That is always the biggest thing. If you get that wrong, everything is wrong, right? So let's practice that. How do you start this, Mr. Erickson? Just go negative, not minus, right? Bracket x plus 4 squared. Don't forget the squared. That's another, I even make that mistake, right? So watch out for that. Plus 5. Hit graph. What's that? What? That looks weird, right? But you can see it, right? Bottom corner. Even if you don't see it, we're going to go zoom 6. Yeah, that solves it for us, right? It's actually perfect. I'm just going to leave it like that. Let's find the vertex just for fun. Just like to have fun on a Friday, right? So second trace, what is this, a min or a max? It's a max, right? Where's my cursor? Oh, there it is. Let's go to the left. Everything in a box to the left. Anyways, so for negative, see that it says -4, 5? If in case you didn't believe me, it is -4, 5, isn't it? Yeah. So it adds up, right? It jives. Good. Let's find our y-intercept. Second trace 1, x is equal to 0. I might be wrong. I will actually test it right now. But let's go x equals 0, and it's -11. 0, -11. If you like to have fun with this, you can actually expand this and turn it into a general form, and then you would have that -11 at the end. Okay, but I think that's too much work. Let's try this. I think I just remembered, like as I learn new things as we go, guys, and so let's change our window, our y min. Let's change that to like -1, not -10. Just -1, and then graph it. Do you see your y-intercept? You don't, right? But the calculator, that's the one thing the calculator can find without seeing it. So let's say you come across a graph that you just don't see it. You're like, Mr. Anderson, I can't find it. You're tricking me here, right? Maybe, right? So you go second trace 1, 0. Just try to find the y-intercept, right? Because if you know where the y-intercept is, you're like, oh, okay, it's -11, right? So you kind of know where to change your window to. Because it's not on here, but it did find it. That's the one thing it can find. It cannot find vertex or anything like that unless you see it. You'll probably get an error of some sort. Okay, that's just another side trick. Okay, and watch this common error. I want you to highlight that back down here. Common error. Students think that the constant k is the y-intercept. Okay, very important. Don't mix that up. Don't mix that up. I will ask you to do these two for homework. G of x, what's that? See that? Yeah, I do it on purpose. I want you to see it all so that that doesn't scare you, right? It shouldn't scare you. It's just a letter that someone chose to write that equation, right? Homework. I will try to do this quickly, scan it. I actually have it done here. I have it done. I will scan it, post it. If you want to double check, if you want to know you're doing it right, there it is. Okay, so I'm going to skip this part, go to the next page. Okay, so there's something cool when it's in vertex form. We're talking A and K. Let's write this up top here real quick. Okay, y is equal to A x minus h squared plus k. Just write that at the top so you know what I'm talking about here. Everything right now has to do with A and K. Right? When you're trying to figure out how many x-intercepts this thing will have, I will allow you, you can always type this in and figure it out, but I will sometimes ask you to explain how you know. And that's where you need to mention A and K, right? So if A and K have the same sign, right? If they have the same sign, so let's say they're either both positive or both negative, there will be no x-intercepts. How so, Mr. Dirksen? Well, think about it. If K is positive, K is basically, if you think of the vertex, K tells you if it's going to be negative or positive, right? K is that Y value of the vertex. So if K is positive and A is positive, right? So A is positive, K is positive, right? No x-intercepts. Same thing here. If the vertex happens to be on this side, okay, A is positive, K is positive. So no x-intercepts. At the same time, if K is negative and A is negative, right? A is negative because it's pointing down. K is negative because that Y value of the vertex will be negative. Does that make sense, guys? I hope so. So no x-intercepts there. On the other hand, watch this. If A and K have opposite signs, you will have two x-intercepts. Because if K is positive, right? If K is positive, meaning it's above the x-axis, and A is negative, right? If A is negative, if they have opposite signs, you are guaranteed to have two x-intercepts. On the other side, if K is negative, right, and A is positive, you will still have two, right? 1, 2. 1, 2. I see 4, Mr. Dirksen. No, don't be silly, right? Two different parabolas there. Okay. And then if K is exactly equal to 0, think about it. If K is exactly equal to 0, that means that you're right on the x-axis, right? It's not positive, it's not negative. It's the vertex is somewhere on this thing. So we can have it right there, pointing up. K is equal to 0. A is positive. You still have only one x-intercept. If A is negative, K is still equal to 0. A doesn't matter. You'll have one. So it's a slightly different way of looking at it. Too bad I didn't give you a grid on there to graph these things. Next time. I think you're already quitting time, right? It's quitting time. So what I'm going to ask you to do, based on what I've taught you today, just look at the homework in the description below. I almost wanted to say in the just click on that link below, and it'll take you to the homework, right? So just do that. Have a good weekend.